Welcome to The Explainer. Today we're doing something a little different. We are assembling a crew, a team of cognitive specialists, to pull off what I like to call the perfect academic heist. I'm talking about completely cracking the code for top marks in the Cambridge 9618 Computer Science exam. Specifically, we're zeroing in on one of the most notoriously tricky, trap-filled areas of the entire syllabus, SQL as an industry standard for DDL, data definition language, and DML, data manipulation language. Now, I want you to think of your upcoming exam paper not as this scary, insurmountable obstacle, but just as a vault, okay? It's just a vault. Inside that vault are the exact marks you need to secure your target grade. And the examiners? Well, they've actually left a very specific combination to unlock it. You just need the right blueprint. Whether you're studying syllabus 0417, 0478, 0983, 0984, 2210, or especially 9618, the core logic is the exact same. In this masterclass explainer, we're going to meticulously break down the vault's defenses, we'll bypass the common traps that catch, honestly, like 80% of candidates, and we are going to walk out with a perfect score. Ready? Let's get into it. Okay, so here's our heist blueprint for today. First, we'll look at the great SQL misunderstanding. Then, we dive into the blueprint and core principles. Third is the transformation methodology. After that, we'll do an interactive critical analysis drill. And finally, we'll reveal the examiner's insider secrets. Let's move. So, to really understand this vault, we first have to look at the people who have tried and unfortunately failed to crack it before you. Let's look at two typical computer science students. We'll call them Alex and Sam. Now, Alex is the memorizer. Alex approaches a complex DDL or DML question by completely overloading the page with raw facts. Alex's hand is cramping up writing down every single SQL syntax rule they've ever seen. Select, insert, update, create table, primary keys, foreign keys, the whole shebang. But here's the problem. There is absolutely zero analysis tying those commands to the actual scenario on the paper. It's just a data dump. And then we have Sam. Sam is the rusher. Sam sees the word database in the question, panics slightly about time, and immediately starts writing out a solution. But in doing so, Sam completely misses the crucial command words in the prompt. Words like evaluate, or analyze, or compare. Sam just describes what a database is instead of answering the specific question. So looking at these two profiles, I want you to ask yourself, and be really honest here, which trap do you usually fall into? Are you an over-explainer like Alex, or are you a rusher like Sam? And this brings us to a quote straight from the Cambridge examiners that brilliantly illustrates exactly why Alex's brute force strategy fails every single time. Listen to this. The assessment framework prioritizes analytical depth over superficial breadth. Right. What does that actually mean for you? It means that simply listing out raw SQL commands or showing off the superficial, mile-wide but inch-deep breadth of knowledge about database syntax, it gets you almost nowhere, like literally 0 marks for application. The examiners are actively looking for connected, conceptual understanding that you can actually transfer to unfamiliar contexts. They do not want a dictionary of SQL terms. They want to see you construct a targeted, highly logical solution to the very specific data problem they put in front of you. If they give you a messy pile of metal, they don't want you to tell them it's metal. They want you to forge it into a key. All right, part 1, the blueprint and core principles, decoding the examiner's mind. But hey, before we continue, subscribe to our YouTube channel Ace the Exams at acetheexams_IGCS to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Now, getting back to decoding the examiner's mind, what's really fascinating about this concept of the method mark strategy is how it fundamentally changes everything you do in the exam room. This is the core assessment principle, where marks are awarded for your systematic process and your clear working, rather than just delivering the final execution or, the perfect line of syntax. Think about it. Think about multi-step calculations or writing out complex, nested SQL queries. Examiners consistently report that students find these incredibly hard. Why? Because they only focus on the final output. They try to do the whole query in their head, write it down, and if they miss a single semicolon or misspell a table name, they lose everything. But if you visualize your algorithmic thinking, if you show your step-by-step logic explicitly on the page, you secure these absolutely crucial process marks. Even if your final syntax has a minor error, the examiner can see your logic and award you the method marks. It's a total game changer. So, how do we actually do that? Well, here is the exact procedural framework you need to capture every single method mark available. Step 1. Identify the key elements of the scenario. Before writing any code, ask yourself, what specific tables, fields, and relationships are we actually dealing with here? Step 2. Apply relevant principles. Are you using DDL to structure the database schema, or are you using DML to manipulate the existing data? What specific data structures make the most sense? Step 3. Execute your analysis with clear, documented working. This is where you lay out your algorithmic thinking step by step. Don't skip steps in your head, write them out. And finally, step 4. Verify your results. Look back at your query and ask, does this actually answer the specific business need outlined in the prompt? Following this standardized sequence guarantees you are scooping up all those process marks along the way.
Moving right along to part 2, the transformation and methodology, upgrading your answers. Now stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to @acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions.
Okay, we have our blueprint. Now it is time to actually put it into practice and completely transform those flawed red ink answers we saw earlier from Alex and Sam and turn them into perfect green checkmark responses. Let's see how this methodology builds your mark potential from 0 straight up to 100%. If you look at the left side here, we have Alex's generic answer. It lists raw SQL syntax perfectly. It accurately defines what an inner join is, but it completely lacks context. It's generic. Because of that, it gets 0 marks for application. Ouch. Now look at the right side. This is a top-tier, context-specific answer. This candidate doesn't just regurgitate the definition of a join, they apply it directly to the given scenario using what we call the PEEL framework. P-E-E-L. Point, evidence, explanation, and link. First, they make a clear point about the appropriate SQL command to use. Then they use evidence pulled directly from the specific data table provided in the exam prompt. Next, they explain the logic behind their code implementation. And finally, they link it all back to the original constraints of the question. This logical reasoning transformation, going from a raw fact to a PEEL paragraph, is literally the difference between a failing grade and an A-star.
Now, to truly master this transformation, you have to understand critical analysis. Top-scoring candidates, the ones hitting the highest grade boundaries, they don't just write code, they evaluate algorithms. Notice the trade-offs required in the complexity matrix here. If the command word in your prompt asks you to evaluate an SQL implementation, you absolutely must discuss time and space complexity. You have to analyze the trade-offs and the performance effects of your query. For instance, does your nested select statement take way too long to run on a massive data set? Is it inefficient? You also need to identify solution limitations. Is there a scenario where your proposed DDL structure might break or fail? You must acknowledge that there are multiple ways to solve the problem, compare those solutions, and then justify your final decisions with concrete evidence. It's all about showing that high-level critical thinking.
All right, part 3, interactive workshop. Critical analysis under pressure. Let's dive in.
Okay, team, it is time for an interactive speed drill. We are going to put this methodology to the test right now, under pressure. I want you to mentally step into the shoes of a Cambridge principal examiner. You are going to look at a complex computer science data source, extract the core trends, and find the flaws. And we're going to put 60 seconds on the clock. Imagine a really complex relational database schema sitting right there on your exam paper. Your first challenge, scan the data. You have 60 seconds to extract the core relationship between the tables. Is it a one-to-one relationship? One-to-many? Many-to-many? You have to spot it instantly. Your second challenge, find the flaw. Imagine a candidate writes a paragraph explaining how they would update a specific record, but they completely forget to mention the where clause. Do you realize what that means? It means their DML statement would overwrite every single row in the entire database. Can you spot why that loses all the application marks instantly? Your final challenge is speed writing. Under strict exam conditions, you need to be able to mentally structure a perfect PEEL paragraph to justify your SQL choices in about 30 seconds before your pen even hits the paper. That's the level of sharpness we're aiming for.
So the crucial point here is mastering the 4 specific elements on this comparative analysis master checklist. Whenever you are asked to evaluate or compare SQL methods in an exam, let's say you're comparing 2 totally different ways to normalize a database using DDL, you must hit every single one of these bullets, no exceptions. First, you must identify similarities and differences. Don't just list how they are different, show how they are alike too. Second, you must use comparative connectives. Words like whereas, however, or in contrast are literally magic words for examiners. They signal that you are actually comparing, not just describing. Third, you must support each point with evidence extracted from the binary representations or the data tables provided in the prompt. And fourth, you must draw evidence-based conclusions on the relative importance of your points. Basically, which method is better and why. If you do this, you're demonstrating the exact true evaluative thinking they want to see.
Moving into Part 4, the examiner's insider secrets, top mistakes to avoid.
We are nearing the end of our heist here, and it's time to extract the final, most valuable payload. This is highly actionable intelligence pulled directly from the Cambridge Principal Examiner reports. Look at this massive flashing red examiner alert. The absolute classic mistake seen across all 9618 papers, but especially when dealing with SQL, DDL, and DML, is providing generic answers that are not specific to the question context. I literally cannot stress this enough. Rote-memorized SQL facts will score 0 if they are not explicitly tied to the specific scenario provided on that page. If the exam question is about a hospital database, your answer must reference patients, doctors, and appointment fields. If you just write down a textbook definition of a primary key without ever mentioning the patient_ID, you will lose the mark. It's that simple. Always link every single point you make back to the given scenario.
The examiners have also highlighted 3 fatal traps you must avoid at all costs. Warning number 1, forgetting to check overflow and edge cases in your SQL implementation. When you're manipulating data, what exactly happens if a value exceeds the field size? You have to account for that. Warning number 2, missing boundary conditions during the rigorous testing phase of your algorithmic thinking. If you don't test the extremes, your logic is flawed. And warning number 3, exactly as we just discussed, failing to provide context-specific answers. Now, if you can avoid these 3 traps, you are setting yourself up for a major grade improvement. Seriously. Students who implement these computer science strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams at @acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to @acetheexams_IGCE and click that bell. Don't let another exam pass you by.
So we've laid out the entire blueprint. You now know how to decode the command words, you understand how to use the PEAL framework to achieve true analytical depth, and you know exactly what the examiners are desperately looking for regarding method marks and context. The vault is wide open, so the final question is entirely up to you. Will you fall back into the generic answer trap like Alex, or will you use the method mark strategy we learned today to pull off the perfect score in your next Cambridge exam? Drop a comment below with your target grade for computer science and the biggest challenge you're facing. Our team responds to every comment. Like and share this explainer with a study partner. Ace the Exams. Your Cambridge success starts here.